Hi everybody, I'm Ivano Malavolta and today I will present our study on mining and empirically evaluating green architectural tactics in robotics. This work originates from the observation that today robotic systems are central to many industrial sectors, such as logistics, autonomous warehousing, and healthcare. Robotic systems play a non-negligible role in the amount of energy consumed worldwide, and improving the energy efficiency of the robotic systems can lead to substantial benefits in terms of environmental impact, obviously, but also in terms of their overall quality of service. Saving energy in a robotic system is not a new problem, but in this study, we tackle it from a different perspective. We look at the software architecture of those systems. It makes completely sense to do this now, since in the last years, software is becoming the prominent aspect in robotics, and it is becoming more and more large and complex. At the core of this work lies the concept of architectural tactic, which can be defined as a specific design decision that is influential for improving the system in terms of one specific quality attribute. In this study, we aim at identifying tactics targeting the energy efficiency of the robot as quality attribute. And we do this by mining the software ecosystem of the robot operating system, which is the de facto standard for developing and prototyping robotic software. Then we conduct a controlled experiment for assessing the impact of the identifying tactics on the energy efficiency of a real robot. The process for identifying the tactics is composed of four main phases, where in the first phase, we build a dataset containing all entries of the ROS ecosystem, independently of whether they are about energy or not. Then in phases 2 and 3, we identify data points that are related to energy consumption, and at the same time, discuss architectural aspects of the system. And finally, in phase 4, we apply the thematic analysis for rigorously extracting the green tactics. At the end of this process, we obtain a catalog of 4 green architectural tactics for robotic software, which have been applied by practitioners in real projects. As an example of tactic, the E4 tactic of our study is called on-demand components, and basically it starts new software components only when their functionality is needed. About the experiment, we implemented a minimalistic robotic system running on a Turtleball tree and performing always the same mission. And for measuring the energy consumed by the robot, we built a dedicated circuit based on an Arduino Nano and an energy sensor, which is capable of sampling power at 200 Hz. The independent variable of the experiment are the applied tactic, which can have 6 treatments, the type of movement of the robot, and the type of environment where the robot is operating. On average, the application of all the green tactics improves the energy efficiency of the robots, even though some of the tactics have a larger impact, have a larger effect on the energy consumption, like E4 in our case. Then we also observed that the combination of all the tactics actually improves the energy efficiency more than the application of a single tactic in isolation. And finally, we noticed that different movements and environments, of course, influence how energy is consumed by the robot, but we also noticed that the application of the green tactics still almost consistently leads to having less energy consumed by the robot. This is all for this video. I hope you enjoyed it. I invite you to read the paper for a complete discussion of the details and obtain results.